So yesterday we talked about the dot product. It is a way to multiply two vectors and get a number. A scalar is what we call it. Okay. When we are in 3 dimensions, there is a way to multiply vectors and get a vector. It is called a cross product. Okay. And this is how we find it. If we have a vector u and a vector v, then the cross product is what you get when you put ijk, vector u, vector v in a 3x3 determinant and do this math. Probably something you should write down. Throw that up. It is different than a dot product. Still multiplication, but very different. Are you trying to fit all of your notes onto that goal sheet? Now it's all just 3x3 determinants. Okay. All right. Do we have written down what we need? Okay. So what's going to happen is we are going to put, so ijk has to be your first row. If it's u cross v, u is your second row, v is your third row. Okay, and it's just the components. You'll do your copy paste your 2 columns, criss, minus cross. Okay, and we'll go through a couple examples and so you can kind of get it figured out. But all of our products are going to involve an I or a J or a K. So we will combine like terms and we will end up with a vector. Something is special about this vector and we'll talk about it here after a while. Okay, so let's go ahead and write down vector u is 6i plus 2j plus k, and vector v is I plus 3j plus k. Write it down. So to find our cross products, notice how the multiplication is an X instead of a dot. Do you see the difference? We're doing a cross product instead of a dot product. So ijk is our first row. Since we're taking u cross v, I'm going to take the components of u, 6, 2, 1 for our second row, and the components of v, 1, 3, 1 for our third row. Okay. So now we're going to copy paste our first 2 columns. We're going to multiply here. So I times 2 times 1 is 2i plus j times 1 times 1 is J plus K times 6 times 3 is 18K. Minus, in parentheses, we're going to do our other diagonals from the bottom up. 1 times 2 times K. Plus 3 times 1 times I. Plus 1 times 6 times J. Okay, so now it's just a matter of combining like terms. We have 2I minus 3I. Negative I. We have J minus 6J. Minus 5J, right? And then 18K minus 2K would give us 16K. Okay, so here's our cross product. There is something special about this, but we'll talk about it in a moment. Okay, what questions do you have on the process? Okay, so now we're going to try V cross U. Okay, so what's different about V cross U? Okay, the second and third row are going to be different. So does anybody think this is going to be the same? No. Okay, yes. We're going to figure it out. So 1, 3, 1 goes in the second row. 6, 2, 1 goes in the third row. You and the people at your table are going to work together to get this cross product for me. Ready, set, go. Doing a determinant in your head for a 3x3 is not advised. Eric, what'd you get? Whoa. What's true about U cross V and V cross U? You were right the first time. U cross V is going to be the opposite of V cross U. Interesting. Just curious at that. Okay, so let's go through some things that happen with cross products. So the first thing, you just wrote it down. You guys, you don't have to write these down, but this one you can write down. U cross V is the opposite of V cross U. Okay. Since the rest of these, let's just talk about, you don't need to write them down. Okay. Since the cross product is multiplication, multiplication is distributive. So that's what this number 2 is, U cross V plus U cross W. Okay. We talked about this with the dot product when we talked about it originally in chapter 6. If we have 2 different multiplications in one problem, you do one multiplication at a time. So you're either taking U cross V and then multiplying it by C, or you're taking C times one of the vectors and then doing the cross product, which I would not recommend. Yeah. I don't know what you're talking about, Bella. Thanks. Okay. U cross 0 or 0 cross U is going to be 0. Does that make sense? All your products are 0. If you take the cross product, and this is one you might want to write down. If you take the cross product with itself, you're going to get 0. Okay, and so then dot product and cross product, it doesn't matter if you do the cross product or the dot product. If you have both of them from left to right, these two are going to be the same. UVW, UVW. Well, no matter if it's the cross first or the dot first. Okay. With a cross product, you get a vector, and so then you can take a vector dotted with a vector to get a scalar. Whoa, crazy. Okay, so what is special about a cross product? So first of all, it's pretty cool that U cross V and V cross U are opposite. So if you know one, you know the other without a lot of work. Okay, but there's something even more special about them. When you take the cross product is going to be orthogonal to both of your vectors. I don't know why people aren't writing this down. U cross V is orthogonal to both U and V. What does orthogonal mean? Perpendicular. What also does it mean? Yes, what also does it mean? Something equals something. Do you remember? Something equals 0. You did it in your homework yesterday. The dot product is 0. Okay. Now, how many of you are in physics and have talked about the right-hand rule? Something about like this.
Radical 3 over 2.
It might be a physics 2 thing. Okay, so this is actually something you use in physics. You take 2 vectors, you create one that is orthogonal to both. I don't really know how the hands all works, like this. Okay, but your vector is perpendicular to both U and V. It's something that's actually very helpful when you get into writing lines, writing planes in 3 dimensions, okay? So let's talk about this that we did earlier. We already wrote this down, okay? And we found that U cross V was -I minus 5J plus 16K. Did I remember that correctly? And V cross U was the opposite. Okay, so let's just look into this, all right? I want to take U dot U cross V, okay? So I am taking U and U cross V and we're taking the dot product, okay? So I'm gonna take 6 times -1, and I'm going to add it to 2 times -5, and I'm going to add it to 1 times 16. What do we get? Cool. Okay, now let's do it with B. Okay, so if we do the dot product with U cross B and B, we take 1 times -1, and we add it to 3 times -5, and we add it to 1 times 16. What do we get? Which we should. No matter what I do, if I take the cross product and I dot it with one of the other original vectors, we're going to get a dot product of 0 because our vectors are orthogonal to the cross product. Sweet. Okay. Now, why is this helpful? Okay. If we have a parallelogram in 3 dimensions, how do we find an area of a parallelogram in 2 dimensions? Yes, base times height. Okay. Now, for math that okay. Oh my goodness. Mrs. Holman had a rough go. The volume? What? The volume? The volume of a parallelogram? Who is this lady? Ugh. I'm so embarrassed for myself. The area of a parallelogram with adjacent sides, vector A and vector B. We can take the cross product, find its magnitude, and that is the area of our parallelogram in 3 dimensions. Right? That's pretty cool. Patton doesn't even know what to say. You don't know what I just said? A parallelogram. Do you know what a parallelogram is? Huh? It's a special parallelogram. Okay. So if I know the vectors of the 2 sides, I can find their cross product, and with that cross product, find the magnitude, and that is the area of our parallelogram. Okay. Okay, so here are our adjacent sides. Maybe write them down. Whatever. There it is. Okay. We're going to first find U cross B. Okay. So we have I, J, K, 1, 2, 2, 1, 0, 1. My vector I plus K does not have a J. Yes, and so we got to put a 0 there. Okay, so we have I11, J20 that we're copying for our columns. All right, so we have 2I plus 2J plus 1K. You're not even paying attention.
No.
Sorry.
No.
What is the third product? 0K. Summers and 0. Minus the quantity 2K plus 0 plus J. So our cross product, we have 2I plus J minus 2K. Yeah. So it does not matter if you do U cross V or V cross U, because when we find the area of a parallelogram, because we're going to find the magnitude and their magnitudes should be the same. Okay. So let's go ahead. The area of our parallelogram, which is the magnitude of our cross product, whichever one we take, square root of 2 squared plus 1 squared plus 2 squared gives us 3. And we're talking about area, so we're going to talk about square units. I found the magnitude. Yeah. Yes, I do have one more thing to teach. Are you okay with that? Okay. One more thing, and then we're gonna be done. It's called the triple scalar product. Sounds amazing. How long is it? No.
Whoa, there does that look.
Okay, we have vector U, we have vector V, and we have vector W. Just like drop your pencils for a moment. If I'm asking you for U dot V cross W, you could either take the cross product by doing your little matrix thing, then you could take the dot product, so then there's more multiplication, or if you have U dot V cross W, you can make a determinant with row 1 U, row 2 V, row 3 W, and do the determinant and get your scalar, boom, in one shot instead of doing 2 different calculations. Are you okay with this shortcut? Write it down. I really don't care what you think. Dang it. That was you.
Oh, no, this is Eric.
Eric, you're supposed to be the nice one in the group.
I am. You could tell who was paying attention. You know, there, it's not correct. Peace out.
Hello. Oh, I did not sing my greeting. I'm sorry. That was Mr. Johnson. I'm not gonna sing for Mr. Johnson. I'll sing for you guys, the one song a year I sing. No, the quadratic formula. You don't remember me singing that?
Do not make Chris. Wow. I love Mr. Johnson.
All right, are we ready for our example? The last example of the year. Woo! I'm the only one excited. Woo! Write them down. Write them down. Okay, so if we take U dot, wait, yeah, V cross W. Just make sure they go in that order. So 2, 0, 1, 3, -1, 2, -1, 5, 2. And I actually like the triple scalar product better because I don't have to worry about I, J's, and K. I can just find a number. Yeah. Yeah. Well, I just from left to right go in that order. Okay. All right. So we get -4 plus, what's this product? Thank you. Plus 15. And then we're going to subtract. What's this product? +1 plus 0. So we have 11 minus 21. -10 is our answer. Now, Hank, drop the pencil dramatically. It's disappointing. Okay, there we go. That's it. And you have 11 minutes to start your homework assignment. You need to do 3 problems before you leave. 3.
Nope. Shut up.